Some quick notes about derivatives. Derivatives are a fundamental concept in calculus that represents the instantaneous rate of change of a function with respect to one of its variables. Essentially, a derivative tells you how quickly a value is changing at a specific point, which is equivalent to the slope of the tangent line to the function's graph at that point. Key differentiation rules. Differentiation is the process of finding a derivative. The basic rules simplify this process for common types of functions. These are the rules we will visit in this video. So let's move on and start with the power rule, which is also the fundamental move. When x to the power of n is differentiated with respect to x, the derivative is n times x to the power of n minus 1. The power rule is used to differentiate functions of the form f of x equals x to the power of n, where n is any real number. For example, if f of x equals x cubed, then the derivative equals 3x to the power of 3 minus 1, and that equals 3x squared. Note that f prime x is another way of denoting d by dx of x cubed, when f of x equals x cubed. Here's a mnemonic to help you remember the power rule.
Bring the power down and then reduce the power by 1. Bring the power down and then reduce the power by 1. Bring the power down and then reduce the power by 1. Bring the power down and then reduce the power by 1.
Next, the constant rule. It tells us that the derivative of a constant is 0. For example, if f of x equals 5, then the derivative equals 0. Note, as implied in the earlier example, that f prime x is another way of denoting d I dx of f of x. Also, the letter z is usually used to represent a constant. Next, the constant multiple rule. When a constant is multiplied by a function, the derivative is the constant multiplied by the derivative of the function. For example, if g of x equals for x cubed, meaning that c is for and f of x is x cubed, then the derivative equals for times 3x squared, which equals 12x squared. Next, the sum and difference rules. The derivative of a sum or difference of functions is the sum or difference of their derivatives. For example, if f of x equals for x cubed minus 5x squared plus x minus 2, the derivative of f is just the sum or difference, as in the original expression, of the derivative of each term. Simplify the expression to get the final answer. This rule is straightforward, isn't it? Next, the chain rule. The chain rule is used to differentiate composite functions where one function is nested inside another. H of x equals f of the g of x. For example, if h of x equals x cubed minus 2 all to the power of 5, this means that f of x equals x to the power of 5, and g of x equals x cubed minus 2. Let's see how to work this part out. Since f of x is x to the power of 5, its derivative is just 5x to the power of 4. But what you need is f prime of g of x, so you replace x with g of x to get 5 times the quantity, x cubed minus 2, all to the power of 4. This is done. Compare these two expressions. Should be quite easy to do the derivative directly, right? Now for the derivative of g. This part is easy, right? So this is the derivative of h. Simplify to get the final answer. Here's a mnemonic to help you remember the chain rule.
Derivative of the outside times the derivative of the inside. Derivative of the outside times the derivative of the inside.
Next, the product rule. The product rule is used when a function is the product of two other functions. H of x equals f of x times g of x, for example, if h of x equals this expression. This means that f of x equals 2 times x to the power of 4, and g of x equals 3x plus 1, all to the power of 5. Differentiate f of x, multiply by g of x. Then differentiate g of x, then multiply by f of x. Then simplified. This rule is fairly straightforward, isn't it? Here's a mnemonic to help you remember the product rule.
Derivative of the first times the second plus derivative of the second times the first.
Next, the quotient rule. The quotient rule is used when a function is the quotient of two other functions. H of x equals f of x divided by g of x, for example, if h of x equals this expression. This means that f of x equals 3x, and g of x equals x minus 1, all to the power of 5. Differentiate g of x, multiplied by f of x, minus the derivative of f of x, multiplied by g of x. Then divide the difference by the square of g of x, then simplify. This rule is fairly straightforward, isn't it? Here's a mnemonic to help you remember the quotient rule.
Low dear high, minus high dear low, over the square of the low, the denominator.
Note that high refers to the numerator. High d refers to the derivative of the numerator. Low refers to the denominator. Low d refers to the derivative of the denominator. These first 7 rules are the most basic ones. Others will come along, but you will always end up using one or more of these first 7. Here's a preview of some trigonometric rules, and rules regarding the natural log and the exponential function.
Sin becomes cosine x, cosine lx. Sin becomes cosine x, the one is so nice. Cosine z is minus sine, minus sine. Cosine z is minus sine, don't forget the sign. Tangent z is secant squared, secant squared. Tangent z is secant squared, always be prepared.
The eternal function. I'm eternal. I don't change. Me and my derivative. We're both the same. The simple result. I'm the natural log with the simplest possible function. So my derivative is the simplest possible rational function.
Unfortunately, math is not a spectator sport. You need to practice. You can create more resources for yourself using Gemini. The link is in the description box below. For example, I can key in this prompt, submit my request and wait for Gemini to generate the quiz. Be patient. AI is fast but also needs time to generate diagnostic quizzes.
Hey, nothing works.
You know it's not ready when you see this number still changing. When it is done, select your option. If unsure, you can ask for a hint. If you choose the wrong option, Gemini gives you feedback on why it's a wrong answer, and also gives you the correct answer and explains why it's right. If you choose the right option, Gemini explains why it's right, just in case you were only guessing. When you are done, Gemini gives you feedback on your performance and gives you options on what to do next.
Take your pick and have fun learning. 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 Have fun.